Hello again and welcome to GCSE Computer Science Theory. This video is on Unit 1, Linear Searches and Binary Searches. We'll start off with a linear search first, and to try and illustrate my point I'm going to move to Microsoft Paint. I do apologise in advance for my shoddy paint skills here, but I'm going to do the best that I can. Alright, so let's say we are looking for the number 71. And when I say that we're looking for the number 71, we don't mean the indexes at the top, we mean the items in our list here. This index is just for keeping track of positions. So, a linear search, it looks through each item one at a time, one by one, going from the left to the right. So let's start off. Is 71 at index 1? No, it isn't. Is it at index 2? Nope. Is it at index 3? Nope. What about index 4? Nope. Is it at index 5? Yes, it is. So then we would output to our user, item was found at index 5. Do we stop or do we carry on going? That is the question. In this scenario, we're going to carry on going right to the end. The reason why we carry on going is just in case there is duplication of data. For example, we've got fish in our list twice, so it would make sense to make the algorithms go right to the end, just in case there are duplicates. Okay, next we'll move on to a binary search, and I'm going to use Paint again for this example to illustrate my point. You'll notice there's some differences about this list. I'm only using integers to keep this example simple. Also, you'll notice that this is in ascending order. Now, with a binary search, your data needs to be in some kind of order for it to work, and that will become apparent while we're doing the algorithm. Now, a binary search centers around looking for something called the midpoint. So let's say we're looking for the number 90 in our list. If this was a linear search, we'd have to search through each thing, left to right, and it would take us 7 attempts to get to 90. What if I told you with a binary search, it's going to take no more than 3 searches to find this number? Let's try it out. So, first of all, we need to identify the middle of this list. Here's the problem. This list is an even number, so finding the middle is not a straightforward job. So, we could either say this is the middle, or we could say this is the middle. Now, for this particular example, I'm always going to round down in the event of ambiguity. So I'm going to call this the middle here. Now, because 43 is less than 90, we know, or rather the computer knows, that 90 must be in the right side of the list. So let's move this over to the middle here, and we can ignore the left side of the list. So again, this is ambiguous, so let's round down. And there we have it, we've found 90 already. Let's try that with another example. Let's try it with, I don't know, 2. Let's try it with 2. Okay, so first of all, we find the middle point and we round down. 2 is less than 43, so we know that it must be in the left side of the list. And this is ambiguous again, so let's round down. 0 is less than 2, so we know that 2 must be in the right side of the list. And this is ambiguous again, so let's round down. And there you have it. That is your binary search done. Now, I just wanted to show you one more slide on this topic, and it's a comparison of a linear search and a binary search at a glance. So a linear search is a very easy algorithm to code, but it's really slow. So in our example of 8 items, a linear search would have to do 8 comparisons. However, with a binary search, only a maximum of 3 comparisons is needed. So a binary search is really, really fast. The only downside of a binary search is that they are very difficult to code, and the list must be sorted first.